Hi Dr. Firoz, my name is Wong Jin Kang, can call me CK, my metric number is AE180110, I'm from Group A4.5. Today I will do the presentation for the subject BEV40301, which is Power Engineering Lab 3. The lab of today is Time Lab 4 Relay Test, and now I will present the explanation. The first question is Function of EFR, refer figure 1, what is current and time setting in EFR. The function of EFR. Earth-fault relay EFR is a type of relay that detects fault between the phase and the earth, and EFR primary function is to detect leakage current to the ground. This relay have the ability to detect higher fault current, thus EFR is used to protect the equipment. High current flow to the ground neutral of the transformer when there is a phase to ground fault. These faults are detected via an EFR. Typically, its input is provided by an external CT, and its output is delivered to any breaker, such as NCCB, which then perform the tripping mechanism. So an EFR is a monitoring device that device input from a CT and output to a breaker. As a result, when a fault is detected, the EFR triggers the circuit breaker. And current setting in EFR. The current setting is the value of current set for the relay trip when fault current closing equal to or exceeds the value of current set. Time setting in EFR. Time setting is the adjustment of traveling distance of EFR after fault current closing current setting. And my friend will continue to the presentation for the next question.
Assalamualaikum to Dr. Muhammad Firoz. My name is Sharifah Afrina binti Said Yusof. My metric number is DE190146 and I am from group A4.5. So now I will explain the connection of EFR to CT, busbar and MCCB. As we know, EFR is used for protecting from earth fault and used with MCCB. And EFR is connected via 4 separated CT current transformer here. So pin 1 of EFR will connect to the red phase, and pin number 8 of EFR will connect to the neutral phase at the bus bar. So pin number 2 here will connect to the input supply of the CT, while pin number 7 here will connect to the ground. Pin number 3 here is for the switch of the EFR that connect to the auxiliary supply, while pin number 5 here also for the switch but connected to the neutral phase. Next, I will explain the function of CT, busbar and MCCB in the circuit. So as we know, a current transformer is a measuring device that is used in relay circuits for protection. CT is an important measuring device for alerting any release or circuit breaker. So it gives alerts when they detect any abnormal current. So there will be a CT for each relay arrangement to measure the current flowing to the main wiring circuit. The CT detects any abnormal current flowing through the primary winding of the CT and the proportional current flowing through the CT secondary winding to the relay. Next, busbar. A busbar is a collection of conductor that collects and transfer electric power from entering feeders and outgoing feeders. In other terms, it is a form of electrical junction where all incoming and outgoing electrical currents come together. Electrical busbar are usually made up of number of lines that all operate at the same voltage and frequency. Next is MCCB. MCCB is a circuit breaker that protects against overload and short circuit fault and is also used as a switch to the circuit. MCCB trips if it detects a short circuit or an overload in the circuit for an extended period of time. So it provides an effective protection in applications that require discrimination, adjustable over alert setting, or a fault protection. Now I will explain the function of each pin or point in EFR. So the first is pin number 1. It is for negative terminal for auxiliary power supply to operate the relay. Pin number 2 used for positive terminal that connect to zero current transformer that acts as a sensor. Pin number 3 is for terminal for normally open that always in that condition and on when the current exceeds from the set value of EFR. While pin number 5 is terminal for com that act as a bridge between power source and MCCB. Pin 7 is for negative terminal that connects zero current transformer and function as sensor. While pin 8 is positive terminal that connect to auxiliary power supply to operate the relay. Last is I will explain about the function of secondary injection test set. So the secondary injection test set function is used to test the trip function of breaker, whether it is magnetic, thermal magnetic, or digital. So the secondary injection test directs a ratio or inject a ratio of the breaker fault rated current into the trip unit and measure how long it takes for the breaker to trip. For the secondary injection test, we can also there is also another method where we can check the timing and also the functionality of the trip unit. I think that all from me. Thank you.
Assalamualaikum to Dr. Muhammad Fairuz. My name is Siti Hajara binti Abdul Aziz Krish. My metric number CE1900331 from group A4.5. So I will continue to explain about the connection of secondary injection test set to the EFR. Based on this diagram, we can see that this is a bit pin in the EFR that will be connected to the secondary current injection test set, which is a Mega SCITS 100. This is the pin that include in the EFR. So the pin 1 and the pin 8 is the auxiliary supply, which is connected to the 240 volt AC. Next is the pin 5 is a normally closed contact, and the pin 3 is a coming common contact, and the pin 2 and pin 7 is the CT input, which is currently from input for the EFR. Next is the method to perform the EFR test using the secondary injection test for checking the minimum current setting. For checking the minimum current setting, we need to test on the EFR protection relay by determining the minimum current setting utilizing the secondary current injection test. To generate a secondary current in the ZCT, a single phase primary current is typically injected into one of the primary conductors. Then, before beginning the test, check that the CT's primary circuit is de-energized, and then connect the EFR to a 240 volt external power supply. Then the secondary current injection test should be set to 0 until 10 ampere and 0 until 240 volt AC. Examine and document all the details of the relays being examined, including the operational parameters. Then gradually increase the test output current until the EFR element is detected or tripping. Then turn the secondary current injection test set off. So this is the thing that we need to record when we conduct the EFR test, which is what is the brand, the type, the auxiliary voltage, and the serial number. For EFR operational setting, we need to record the service setting, the leakage current in milliampere, and the time delay in second. Next, method to perform the EFR test using the secondary injection test for checking the operating time. First, connect the secondary current injection test set timer terminals to a relay trip contact, and then start the secondary current injection test set and set the output current to 2.0 multiply with I output or tripping current setting. Then turn off the test set while retaining the control knob in the predetermined position. Switch the secondary current injection test set to the test position to inject the current while also starting the timer. After the relay trip contact is activated, record the relay operating time in the above mentioned test in the test report, and then turn the test set off. Repeat the relay operating timing studies with current injections range from 3.0 to 5.0 and note the result. At the conclusion, disconnect all wires between the test set and the relay. Make sure that all relay connections have been restored to normal working condition. Lastly, we need to record all the results in the timing check test setting, and the unit is in a second. That's all from me. Thank you.
Thank you the presentation of my friend, and now I will continue to the presentation for the method to perform the EFR test using the secondary injection test for checking the operating time. First, connect the secondary current injection test set timer terminal to a relay chip contact. After that, start the secondary current injection test set and set the output current to 2 times of IO, the IO which is tripping current setting. And we turn off the test set while retaining the control node is in the predetermined position. Switch the secondary current injection test set to the test position to inject the set current while also starting the timer. After the relay trip contact is activated, record the relay operating time in the above mentioned test in the test report. Turn the test set off and we repeat the relay operation timing studies with current injection ranging from 3 times to 5 times of IO and note the result. After at the conclusion, disconnect all the wire between the test set and the relay. Ascertain that all relay connections have been restored to normal working condition. That's all my presentation, and thank you.